tonight we're going to be keeping it local with the folks from the group talking. One thing this weekend, Kusai, of course, who spoke at the last meeting, received his PhD.
Yes.
And in the chat, I posted a link to the video of it, so everybody can look at that later. It's on Facebook, but I say the link is there in the chat.
Jim, can you do me a favor and do that again? Because I came in after you posted it, so I can't see it.
I'll put it on the website too.
Yeah, it's right at the top of the chats. I think I posted one, and then Nathan posted a link.
We can't go in reverse to pick them up.
I'll put it on there.
Thanks.
Okay. Let's see. Train of thought derailed.
There it is.
Is that going to get us in any more trouble with YouTube for posting something that you got off Facebook?
No, it's not on YouTube. It's a link to Facebook, so you can watch it later. So that'll probably ensure that there's no issues.
Yeah, as long as we don't incorporate it into this video, we're, I think, okay.
Keep it separate. Just tell everybody they can go watch it on their own. Anybody have anything to share with the group?
Has anyone else had problems with the laptop? I bought one last June. It was only 10 months old and the entire screen went out. I had to send it in and get the entire top half of the laptop replaced.
Oh boy. Well, that's what warranties are for.
Yeah, I was very surprised. I've never had any problem with Apple products before. The screen was totally black.
Did you have the Apple Care Plus?
Yeah, they took care of it. And
Yeah.
Oh, good.
Yeah,
That's what I was going to say.
I was just wondering if that's become a common problem, or is that just one and then off thing?
I've read that some people have some artifacts show up on the screens, but dying like that completely, it sounded like maybe the the cable came disconnected. It could be something real simple, but again, it's under warranty, so they'll fix it.
No, they said that the whole screen was dead. They had to replace the whole screen. Yeah.
I mean, it's electronics. It happens, but
yeah,
it shouldn't be a common thing, but it's been known to happen.
Yeah.
Well, thank goodness she had Apple Care.
Oh yeah.
Well, yeah, it sounded like it's new enough. It's still under the the basic warranty. But I say sometimes the extended warranties are worthwhile.
Yeah.
An old friend of mine who's now high up in the Apple Service Organization once advised me to buy off the Apple refurb market because they were much better tested than the new products.
Sure. I've had good luck with buying refurbs.
Yeah. So it was a case of infant mortality.
Yeah. Let's see, Cokie.
Yes, I'm ready. I'll be ready in 1 second.
If you could tell us about the the donation we made to the blind children's.
Oh, okay. We made a $2,000 donation to the All Blind Children's Organization with the Texas School for the Blind. And we just got a message from the president that they did receive and cash the check. And they are going to try and see if they can give it to some. It's for blind children all over the state of Texas. So So if they have a project that comes up where they need to buy an Apple device or whatever, they can use that money to go towards that. And that's what I recommended for them. And they said that they would do the best that they could.
Do they have some kind of a trust that they could add that to?
They do. They have, it's a full organization, so it's connected with the school. So that they can do those kind of things, but it is all over the state of Texas. So if a VI teacher, say in Dallas, needs an Apple computer or an Apple device, then they could call the School for the Blind and ask if they have any funds available for Apple products in the All Blind Children's
Excellent.
organization.
Yeah, thanks.
Well, that's great. You want to go ahead and on the same vein, talk to us about the Seeing AI?
Yes, I
Yeah.
have a project that is Seeing AI, and it's an app that I bought a long time ago. And when I first used it, we were driving down the road, and I used it and I could catch some signs along the way. And I said, wow, I've never been able to read some of the little street signs along the way. So it was kind of nice, but they've done something new. Now you can take a picture, and that's what I'm gonna do. I'm gonna go, but we'll go where, okay, there it is. Okay, did it come up?
Yeah, we see it.
Yes.
Okay. All right, here's what I'm gonna do then. I'm gonna take a picture. I'm gonna delete, I mean, I'm gonna do on here where it says describe.
Processing. The image depicts a room with various objects and furniture. In the center of the room, there is a large rectangular rug with intricate patterns, placed on a wooden floor. On the rug, a black and white dog is lying on a gray cushion, positioned towards the bottom center of the image. To the left, there is a treadmill with a control panel and handles visible. Behind the treadmill, a wooden wall is visible with several wires hanging down. A small shelf is attached to the wall, holding a few items, including a blue package. In the background, a stone wall is visible, with several boxes and items stacked against it. There are cardboard boxes, some labeled, and a variety of other containers, including a blue plastic bin and a black bag. A large cardboard box with a colorful design is placed on top of the stack. To the right, there is an office chair with a dark blue seat and backrest. Next to the chair, a wooden desk or shelving unit is partially visible, with more boxes and items placed on it.
So you
A
get to hear
stack of
about
books
all
or
my junk.
magazines is also visible on the desk. The room appears to be a storage or utility space, with various items organized and stacked along the walls. The ceiling has visible beams, and an orange extension cord is hanging down from above, adding to the cluttered appearance of the room.
Okay, so that
She
that is
doesn't
my
miss a
living room.
thing.
No
It did,
editorial comments, please.
as you
Right.
can, as you can see, it didn't show, I mean, it showed everything that was there. And this is stuff that's been stacked up for a while. It's in front of my fireplace. And but I've been moving things around a lot lately. So,
Cokie, it didn't give us the name of your dog.
oh, well,
Not
no,
your
it didn't,
dog.
but my dog's name is Heart. She's named Heart, and she's 13 years old. She's a rescue
Wow.
greyhound.
Oh,
Anyway, so that's what it does with Seeing AI now. So as a blind or visually impaired person, like I went outside and I clicked it on outside, and it talked about everything that was in my backyard from where I took the picture at. And it told about my light blue colored storage unit that I have out there that Tommy and I built together. And it had a swing, but it didn't say it was not put together well, but it said a swing. But it gives you a lot of more detail than it used to. So it's really a nice little thing to have handy for if you want to look in a park and see what's going on in a park or something, you could use it for that. So it doesn't just have to be for a blind person, but just to let you know that it's available, and it's called Seeing AI. Okay, and that's all I had to show everybody today, because my friend Zena showed it to me, and I said, oh, I got to show that at a CapMac meeting.
That is very cool.
Cokie,
it
before
is
you go
very cool.
away, before you go away, throughout that narration, the text that's on your screen was static. Would it scroll through the entire narration?
Yes, it does. It's in print, so you could reread it if you needed to. You could use
Okay,
voiceover and reread it if you needed to or whatever.
so you could
Um,
save it.
but yeah, you could clean it up and you can do whatever you wanted to do with it. And I don't know if it has a way to save it or not because I haven't played with it enough to say that. But I just wanted to show you how much detail it gives you.
Yes.
Zena did it from, she lives on the fifth floor of her apartment building, which is, and Kasai lives on the fourth floor. And she took a picture outside her thing and it told about that there was a 3 or 4 cars in the driveway, there were trees and all kinds of things. So it was giving her a lot of detail
Good.
about what the parking lot looked like.
Well, that's
So
very
anyway,
Now, which phone do you have?
I have the 14.
Oh, good. I can do it then.
Yeah,
It says iOS 12 or later.
yeah, iOS
It,
12 or later, yeah.
Oh,
um,
they're going by. Okay.
Thank you for
and
looking,
it's
finding that.
and it's published by Microsoft.
Yeah.
Cokie, it looks like you need to charge your phone before too long.
Oh, yes, I know. I've got it charging. In fact, it's higher than it was. So yeah, I'm already aware of that. It died when it died when it
I did it.
died
I did
when
it.
yeah, when Heidi was talking about charging things and it died.
good.
Anyway, that's my presentation for tonight.
Okay, we
Thank
go ahead,
you.
go ahead and turn
Thank
sharing
you.
off.
Yes,
Thank you very much.
Thank
Yes,
you.
thank you, Cokie. It was very interesting.
you're
Process.
welcome. Oops, sorry. I didn't mean it for it to do that. But let me do the sharing off. Stop screen sharing. Yep,
Yeah.
there we go.
There we go.
I'm off. There we go. Hey, I finally did it by myself. Yay.
Yay.
Okay.
Good, very good.
Applause.
Okay, John, you want to, that'd probably be a good segue into you talking about machine learning.
John's muted.
Sorry about that. I opened it up to share, and the share screen's different than I've seen before. So I'm trying to
I
find,
know it.
there it is.
Yeah, I noticed that. That's what I was having problems with. Go ahead, John.
Those darn updates.
Okay, I got grant access, sorry. Yeah, I'll just do that later. So hopefully I can now share and now I can actually see my screens. So as was mentioned, I am looking at machine learning. We've talked a lot about various AI products, principally various LLMs, large language models. So I thought maybe it would be useful to talk about just exactly what machine learning was at a very high level, because it's a very technical topic. So I put together a few slides, and certainly as I go through here, if you have a question, let me know. So I don't want to just run right over you and have you be lost. So talk about machine learning. So I grabbed a couple of high-level explanations, but the gist of this is machine learning is having a machine that is going to be able to input data, analyze it, and then learn from that data so that it can then come in and analyze other new data and make a decision based upon that new data. And more things about machine learning. It is very mathematical. We'll just touch on it briefly later, but machine learning is based upon a lot of large matrices and extreme amount of computation. That's why data centers that are running LLMs, especially during the training phase, consume huge amounts of power.
Mm.
I'm not going to read all this slides. You guys can read it later. So a little bit about the theory. And the theory of machine learning really goes back to the 40s, 50s, and 60s. It's not something that is new. The concept was developed back then. A very simple approach that conveys the concept is something called the Matchbox Educable Knots and Crosses Engine, the acronym MENACE. This was developed in 1961. Now, this is a total mechanical machine, and machine is a stretch here. So what it does, and when you talk about knots and crosses, they're really talking about tic-tac-toe. Just a fancy name for tic-tac-toe. So for this experiment, they used matchboxes as the part of the machine that was making a decision. And I'll get to how that works later, but it all rolls into how things are done today. So in this case, what they did is they laid out on a large chart every possible tic-tac-toe game board possibility. And then they went through and eliminated any duplicates. And duplicates in this case is, well, if you orient it one way or the other and it looks the same, it was a duplicate. So they eliminated all the possible these duplicates. And after they charted all the possibilities out, they ended up with 304 different possible game board configurations. That's what drove them to use 304 matchboxes. So each matchbox would contain a colored bead. Now notice in the bottom left-hand corner, there's a white square with 9 colored beads in it. So those colored beads correspond to the possible moves in the tic-tac-toe board. 1 is top right, 9 is bottom left, and bottom right, and so forth. So you'd have 9 beads in each of those 304 boxes. Now, in this menace, the system would always play first and would place a 0, and it would just randomly place a 0 somewhere on the board. Now, how this works is then when the machine played, now the human played. The human would then play an X somewhere. The human operators who were running the machine would look at that, look at now their chart of all these 304 game patterns, identify the game pattern that matched the real game, and then go to the corresponding matchbox, shake the matchbox off, and pull out a random colored bead. That colored bead would then tell the machine to where it should move next. It would make its move, and it would be recorded which box the bead came out of and what color a bead came out of the box. The human would play. And so back and forth until it had played through. Now, when it all was over, this process would go through iterating through this process until someone won the game or the game was a tie. At that point, Menace, this manual machine, would be trained. If Menace won the game, then the original bead would be put back in the box, as well as 3 additional beads of the same color. If they tied, the beads would be put back, but nothing else. If they lost, the colored beads would not be returned to the box. So what's happening here is after you go through this, now the boxes will get more or less beads of a given color that would correspond to the best move for the corresponding game board configuration. So this kind of gives you a high-level look at machine learning. That's what happens in the modern software we have today. So before I go any further, do I need to explain this any further? Okay, very good. This was hard to put down in slides.
Yeah.
So if you look at the human brain is made up of approximately 86 billion neurons. And each neuron electrically communicates with up to 1,000 nearby neurons through their axons and dendrites. It is the tentacles, if you will, that come out from each neuron and touch other tentacles from other neurons. In the human brain, what happens is we learn or we try to remember. Connections are either made or strengthened based upon that learning concept. For trying to simulate it, we use what's called an artificial neuron. Artificial neuron can be hardware, but most of the time today, particularly with the large language models we see everywhere, it's all done in software. So you see on the left of this diagram, what is the human brain, neurons with the dendrites and the axons that can connect to other neurons. In software, what you have is a number of inputs, the bluish round circles, feeding into something that sums the values of those inputs. Then it evaluates it and produces an output based on some threshold level. So that's all done in software. Now that's one neuron. So these models have many artificial neurons. So in this picture, you have inputs of green on the left. You have two intermediate layers of artificial neurons and then output. Now notice each input goes to, we at least I had a pointer. Can you see my mouse?
Yes.
Okay, so this helps. So as you see, each of these inputs goes to each of these four. So this is a very, very simple model. Most models that use neural networks, you'll have dozens, if not hundreds or thousands of inputs, and each row will have thousands or even millions of artificial neurons, and you would have several rows of artificial neurons. The way it works is these inputs are summed in each of these neurons. That is fed to the second layer that sums all the inputs to it, and then it produces an output. When you're training the machine, you take and apply data at the input. You let the neural network, I don't know why I'm using my hands, you can't see them that much. You see the neural network will compute a solution. It will say this one output is what's the solution. Then you would look at, okay, this is the input, and you know what the output should be for the input. Then you would go back and, as in the matchboxes, you would reinforce the inputs, reinforce the weights of the inputs to the various nodes in the neural network. Similar to adding or taking away beads in the matchbox example. We can't remember and when I talk about weights, you see here, there's a weight, it says W, but it just says, okay, for this input, there's a weight factor, something that's multiplied times the input and the result summed. So there's weights for each input, and it's the learning is what goes through and adjusts those weight factors, just a number that's used to multiply times the input. So you would do that, you would apply the data, you would compare it to the results, the correct results you know in advance. You would then train the network based upon what it said. You would apply more data, and again, and again, and again, and you would you would not only apply different data, but you would apply the same data again and again and again until this matrix of neurons would arrive consistently at the correct answer. So it's very iterative and computationally complex. So if saying that, what does that mean to a modern LLMs? Well, I just grabbed some information for a couple. For instance, GTP3 has 96 layers and 975 billion nodes or artificial neurons. So in that context, this is a row, and in this row, in that picture, there's only 5 neurons. In and our GTP3 LLM, there might be, what is a rough estimate, 175 million neurons in that row. And you'd have now 96 of these rows that are shown here and massive interconnections. This is a simple neural network. This one just shows feed forward connections. In actual networks, they also do feedback loops where they take output further down into the system and apply it to adjusting the weights earlier on in the neural network. So when you do this, and for instance, GTP4, which we've talked about before, was a step forward in ability over GTP3. GTP4 has a 1.6 trillion artificial neurons. So it's gone up by a factor of 10. So these are getting more and more complex. It's all done in software. It is done with huge matrices and using mathematical matrice operations against them. So it takes a lot of time to analyze the data and train these networks. That's why as I mentioned before, the computational power that is needed is so high, lots of memory and a lot of corresponding power to supply to the system. Now, that doesn't say they're hard to make. There is, for instance, a open source library called Keras, which is available for Python, that allows you to build your own learning or neural network models. You can also find several instances of Python or other programming language code for building up learning networks based upon artificial neural networks. The big thing to remember here is it just has a lot of inputs, and you have to know for a given set of input what the solutions need to be in order to train your network. Some of the simple ones that are often described when you look at literature for doing this is they would take, and I wish I would have grabbed one of the screens, but have a matrix, an image. I'm sorry? Have an image that would be, say, 5 or 6 across and maybe 9 or 10 down of dots. You would then take, as if a camera took a picture of a number, and then it would overlay that on the dots, so it'd light up the dots that were corresponding to the figure of the number. And then say, okay, well, this particular figure, whether it's sideways, left, right, whatever, corresponds to, say, a 7. You keep running it through there until the machine would always recognize that configuration as a 7. You apply a different, maybe you turn the 7 just a little slightly this way or that way, or move it up higher in the screen or so forth. And then you run it over and over again until you can train your matrix to recognize things. So this can be used for anything where you're trying to look at something and identify a pattern out of the data. There are data sets that are available. They're free open source data sets. So you can build your own or write your own code and then use that data set to train it to do recognition of numbers, for instance. So it can be used for machine learning in a variety of ways, image recognition, character recognition, and at the more massive scale, what we've seen with the LLMs. So that, in a really nutshell, is machine learning. I hope it helps. It helps some of you, and I didn't lose you. It was difficult to go through this and go, how do I do this without all the mathematics and all of the extensive background material to get to this final point? To really get into this, you're talking about really a semester long study in college, but or the equivalent to that. It's not difficult. It just takes a lot of time and understand some of the concepts, particularly when they get into these back propagation models to refine the accuracy of the LLM or the neural network. So, any questions?
I have a question. When they're doing all this computation, are they using a very large number of networked computers, or are they finding a way to use the quantum computers to do this?
They're not using quantum computers. This is all just normal computers that we have today. So it's all written, probably not in Python. It's not fast enough, but probably written in C or C++ to actually run the real models, because that runs faster than an interpreted language.
But it would be a whole room full of blades that are
It could be,
right?
But you have to remember that what you would have to do if one machine wasn't big enough, didn't have enough memory to store this huge multi-dimensional matrices, then you'd have to split it up into multiple systems like you're suggesting, but you'd also have to split up the training data to apply to all of them. If you start splitting it up into multiple machines, it becomes a lot more complex in terms of taking the training data and getting it applied across all the inputs.
Okay, thanks.
I think that's where NVIDIA, the company NVIDIA comes in with their extremely high performance, graphics chips that were originally made for making like video games, but found out that they can handle the volume and the speed of computation that's required to build these AI systems.
Yes. And I listened to a podcast just last night, a couple of guys talking about, trying to remember, I think one of the Mac podcasts, and they were talking about how the studio, with its large amount of integrated RAM, is really an ideal machine to run models like this on, because it can have such a large memory. I think they said 92 gigabytes of memory. Wow. Off the top of my head, so I might be wrong. But it also certainly has the computational ability. But remember, you're doing computations where, if I go back to something simple like there, since each of these neurons that you see here, okay, the mathematics on this would be, okay, it would be an array. For that node, it would look at all its inputs, multiply the inputs times the weight factor, sum that up, apply a function to determine whether it was above or below the threshold to fire the neuron, and then it would go down to this one and do the same computation, then this one, then this one, then this one. Then it would go to the next row and apply the same things, and then do the same thing here on this row. So computers, unless you have ones that are extremely parallel, and even then your parallelism is going to be, well, if you have, like on my M4 Mac Mini, I've got, about 8 or 6 CPUs. Well, you can only do 6 simultaneous operations. If you have a neural network that has 175 billion nodes. You've got to perform those multiplications of weights, the summing and the evaluation function 175 billion times. So massive parallel systems would be ideal, but you're still going to need to have many computers to run and divide up the data across all of them for the problem to be trained and for it to be solved.
I have a question, John.
Yes, Nancy.
For those of us who have normal IQs, if somebody, I've often wondered how people who create games like solitaire, where you're going to have, you keep playing it over and over and over and over again, and each time it comes up with a different display of the cards so that somebody can play. Would this system that you're talking about allow a programmer to create a game with unlimited number of formations of the cards being laid out? I mean, this may be not related, but it's just, I'm trying to grab hold of it.
I'm sorry, what kind of cards were you saying?
I like solitaire.
Okay, solitaire. I knew you said, I just couldn't bring it up in my head. The short answer is yes, you could. I don't think that many of them do it that way though, because they've written it all in code. So I think a lot of them are just straight code with random numbers and probabilities worked into it. But you certainly could, like the fellow I mentioned back here doing the Menace machine with just matchboxes and pulling out random beads. It would be easy to write that kind of thing in software. 304 entries would be simple to write up. So yes, you could. And the good thing, if you used some sort of a machine learning approach, is you'd have to write the basic format, but then the game could actually learn from you playing it. Of course, that also means you could probably get it to the point where you'd never be able to beat it.
Yeah. Okay. That helps me put it in perspective of what it is that you're trying to do with this whole concept of machine learning. So thanks.
Okay. If I have time, I'll write a Python program to do this Menace and see, maybe you can show that at a future time. It doesn't look too hard to do. This would have been great to have a lot of things to visually look at and see it doing things, but I didn't have quite the time to do that. And there's not a lot that you can visualize unless watching one neuron make the calculations. So the big thing is the modern LLMs are not so much a product of recent development. The concept has been there a long time. When I taught at St. Ed's, I taught an artificial intelligence course back in the probably late 90s. And one of the things we talked about was artificial neural networks. So it's something that's been around a long time. What's enabled them to become so powerful today are the large machines we have possible today with all of the memory and the tight integration to allow, as Don said, have multiple systems connected together for doing the computation.
Yeah.
Anything else?
I just came back from a genealogy conference, a fairly large one, and they had sessions talking about AI and genealogy, sorting, typing in a guy's name and a birth date and a place, and then the AI is going through massive databases and pulling out marriage, birth, death records, et cetera, that might fit this person.
Mm-hmm.
The other aspect is they're using it for transcribing old documents, because the computer might be able to read some of the old handwriting better than we can.
Yes.
And at least figuring out what might be the what's written on the page.
Well, you may remember kind of in that lane, we're kind of going off into a rat hole here, but not too long ago, there was a young student, I think it was an MIT student, who entered a program in this contest to be able to read ancient scrolls, kind of along the lines of Dead Sea Scrolls. The problem was they were so old, they were stuck to each other. So it's just a rolled up mess of just one layer of writing after another. And he used AI to be able to use, I can't remember how they scan it, whether it's a electron microscope or some kind of scanning device to scan it through that rolled up scroll. His AI was then able to unroll the scroll and to translate the language that was written there. So it can do a lot of remarkable things trying to look at old documents and either parse out the real words that are there that the ink may have been smudged or washed away, so it could fill in. Of course, you got to take with a grain of salt what machines tell you, but gives you an idea. But yeah, so many ways AI is changing our lives, hopefully for the better, but certainly changing. Anything else? Okay.
Well, that's fantastic. Appreciate that.
As I said, if I have time, I'll write up Python to implement Menace and share it with you. I don't think it would be too hard. I just got to find the time. And there's a bunch of references here. As you see in here, I've got numbers associated to some of the things I say, and that ties back to the article or the source that came from. All right, so that's the first of my propeller head topics for tonight. As one of those podcasters I listen to often says when they dig into the real technical stuff. The second is using the Mac OS command line. How many of you, I can't see you, but how many of you out there have used the Mac command line?
I have.
A couple. All I can see is 5 people on this little strip here. So probably most of you have not, but it is there. It is the way I learned Unix back years ago. So that's what I'm going to talk about tonight. And we got a lot of time. I have a hard cutoff, according to Tom, by 9 o'clock. So I'll go through whatever I can between now and then and see how far we go. So the Mac command line. So what does that mean? Well, the first thing is you got to get to the Mac OS terminal. Now, to get to the terminal application in Mac OS, you just go to Finder, Go, Utilities, and then once it shows what you have in the Utilities folder, double-click on Terminal. Now, let me unshare. I always have a hard time remembering where unshare is. Oh, there it is. And let me share again. You should see my terminal.
Yep.
Okay. So there it is. It's writing it out to you. So let me pull up my notes that I made, because unlike just going into this blind, I went through and wrote out all the things I wanted to say so that everything I had, I knew how the outcome was going to be. So get this over here. You should see that. And this is what terminal looks like. Now mine's customized a little bit. So if you pull up your terminal app, you probably won't look quite like this, but it's going to be similar to that. And if you go up, you should see this. No, I don't know if you see that or not, but you have a number of ways of customizing your terminal, how big the lines are, or the text, the width, the height, colors, all of that stuff can be customized. Mostly it's, well, what's the best way for you to look at it? I picked a gray background because there are some things that I'll pull up that is black, some things that are colored. You need a neutral background to be able to get both. I wanted to use black with red text, but then I found that, well, some things put up black commands, so it just looked like empty screen space. So there are a tremendous number of commands that you can use through the terminal. Keep in mind that Mac OS is a derivative of Unix. So all of the Unix commands are available at the command line terminal, as well as a number of specialized commands for Apple. And I don't think I have in what I was going to talk tonight about, I may have one or two special for Apple, but most of this is just generic stuff. So I'm going to go through and show you some of the simple things and then get into some things that you might actually be able to use. So one of the things that quite often you want to use is when you get to a command, you want to know, well, what is this command and how do I use it? So there's actually a command to look up the command. So that command is called man, M-A-N. And just to be for grins here, I'm going to say, well, I want to know about the man command. So I'll do man. And so now here's all the stuff about the man command. Notice here in this, you can barely see my cursor, but in this section you have all these. Well, there's man. Oh, then there's a -T. Oh, then there's a -W, and so on and so forth. In the Unix world, these are known as switches for the command. So you can give various subcommands to the command. It says, I want to do this command, but I want to see the output look like this. I want it to be, the sizes be human readable. I want this, that, or the other. And we'll see some examples as I go through this. So if you really want to be a power user with these commands, you would either have to know these switches or use something like man to look them up and see, well, if I want to do X, here's how I customize the input to do that. And this, we only see one screen here, but notice down in the bottom left corner, there's a colon. The colon says, well, here's part of it, but there's more. So I want to see more. I can hit enter and I'll read one line at a time. That's not too effective, but I can hit the space bar and read a whole screen at a time. And you see here all of these different switches available for this one command. And so I keep going on all the way down. So I finally get to the bottom. To exit this, I can hit Q and it quits that. Goes back to the command line. And I should say, notice here on my command line, this, I've sort of customized this. So it gives me as the user, when you log in, you have a user ID. And then I've given a name to my machine. And again, you can customize that to all sorts of ways to include other things and make it in color. And when I was at IBM, I had a whole lot of stuff like that. So now that I've talked just a little bit, we can look at one of the first commands. And I'm going to do, let's look at it, PWD. PWD says print working directory. So it is essentially saying, I want to know where I am. When you're in the command line world, you can go off and start doing things and suddenly you go, well, where am I? What level within the directory structure am I? And that's what PWD tells you. So if I put in PWD, it tells me I'm at /users/JR Purvis. So in the Unix world, that says that is my home address. Slash is root file system, the very base level. Users is one of the base level directories. And then there's another directory for each user on your system. That's what that means. So it kind of gives you an idea. So now, while I'm there, what's there? I can use another command, and I'm not going to go to man for these unless we really need to. So let's say I want to list every file in this current directory. And to do that, I use ls. And I hit it and it says, okay, here's all these files. Well, that doesn't tell a whole lot other than the names of these. And it doesn't tell me even much about what they are. Now I can augment this a little bit by saying ls minus capital G, and it says, oh, well, do it in color. And it's colorized to match different types. In this instance, the blue represents folders, directories in Unix term, folders in what we say in the Mac OS world. So I can see it a little differently and get a little bit more input. If I do it again, and I'm going to call it up real quick without, I'm not even going to talk about that. Do that, I've added S to it. S says sort by size. So now, okay, I've relayed out all those, but now they're up here, listed here by size. And if I wanted to see the size of each individual folder here, now it shows 0 for several of these because they're directories, or it doesn't show the size of a directory because a directory really is 0 size, almost 0. But about PY is 8. Well, 8 means 8 1024 byte blocks of data on my disk. So this gives you an idea of the size. I can do things like ls minus u, and that sorts these a different way. Now it's sorted by the last time I accessed anything, or ls minus u sorts by time of that was time of last access. I did it twice, and I could do ls minus lh, and now it shows the file sizes in human numbers, and human readable numbers are what are shown right in here. You can see my cursor. This file about py is 183 bytes. So it's really small, 1.5K for this, and so far down the list. So you can find out information about your files. Now, having done that, I'm still back here in my home directory. What if I want to go to a different directory? To do that, you use the cd command, which cd corresponds to change directory. And let's say I want to go to documents. And when I was typing this, you notice I hit DOC and then suddenly it filled in. Automatic completion is provided here. So if I start typing something, let me go back. If I go here and I type tab, it will try to autocomplete, but it goes, hey, I don't know, you have 3 directories that start with a capital D. Which one do you mean? If I say, let's say add 0 here and do it again, oh, okay, well, it's not the other one I just put in, but it's either documents or downloads. If I say doc and hit tab, it goes, oh, I know which one it is, and it auto completes it for me. It makes it easier and faster to run through things. So I cd documents. Doesn't tell you a whole lot there, except in my command line, it tells me the current file. But I might say pwd again. Where am I? Well, I'm at users Purvis documents now. Now I can look at what's in that. And if I want to say, okay, I'm done working there, I want to go back home. Again, home was where I started. All I have to do is type cd with nothing else, and it goes back to home. And that's true wherever you are in your system. Or if, let's say I do CD doc, do that. And I've got some things there, CD. I'll go to the web documents directory. I don't know what I've got there, but some stuff. So I'm there. I could type CD and go all the way back to my home directory, but there's also a thing that if I do CD space ... it takes me up one level in the directory structure. So it's a faster way of getting around. So I mentioned before, where is home? And home, remember, is that directory right there, users/JR Purvis. Well, how does the computer know that's where my home is? Well, that's because every user has an environment file that specifies things about that user. If I want to see that, I type in env for environment, and now it's listed a number of things. And I'll tell you what, let me do this. Makes it less busy there. So it tells me here a number of things, and my home is highlighted. So every user has this environment files that says where their home is. What directory is the home for their files? And notice here I've got my username and login name, the shell. What I'm running right here is a shell. It's a program. It is a user interface. Each shell, and there's half a dozen or so different shells that you can be in, has its own scripting language and own peculiarities associated with it. So you can do things there, and sometime I might show that, but it certainly won't be tonight. The other thing I might point out is path. Path says, okay, well, when I type in a command to run, where should I, as the computer, go to look for those commands? And so path says, here's where you should look. And you start from the first directory, and the first directory would be right there. And then if the command I entered isn't there, it would go to the next one, and then the next one, and then the next one. So that's how the operating system knows to look for your commands in a particular spot. So you can have programs that everyone on the computer can access. You can have programs that only you can access because they're in your executable directory. And behind the levels that you see when you're in Mac OS, this is how it's laid out. Sorry, I had about 90 kids at the museum today, and I had them for an hour and a half on a tour, and I talked to people all day. So I'm about talked out. Oh. So we've done that. I'll enter clear again to get the screen. Makes it so it's easier to see. And I'm just doing through some very simple things here. Another one is, well, I want to see a calendar. I can type CAL, and there's the calendar. Tells me the month I'm in automatically, what day of the month, highlights the day of the month, and tells me the week, the day of the week we currently are. And you can use this in a number of ways. Easy to see. Similarly, there's date. Date tells me the current date and time. You can actually go in and customize this as well to tell it, how do you want to tell you the date and time? You want a 24-hour clock, you want AM and PM, and so on and so forth. These kind of things are useful when we'll touch on later. You want to combine the output of commands to achieve something. Okay, we did that. I'll send Robert my note sheet here so that you can read what I wrote up to tell you about in addition to getting the video when it's finally done. So there's another command that's pretty useful called du. Du, sorry, I got to type right. It's hard to type and talk at the same time. Du says disk utilization. So if I type du, it's going to tell me disk utilization of the current directory I'm in, and that is in documents. If I go up one level, now it sees a whole bunch of stuff because I got a lot of stuff in that higher level directory. Okay. Let me stop that because we got way too much. So let me CD again to desktop. So du says how much space is used in the desktop directory. And in this case, let me go up a couple of lines because there's something in front of it. So it says I've got 120, so much space used, okay? So I want to see that and go, well, is that a better way for this to read? Let's go to man du and see. And man du, notice if we go down here and say, oh, I can use the -H switch to see it in human readable form. So now I go du -H, and instead of saying 27, now it says, oh, I've got 62 meg of files stored within the directory desktop. So it's easy for me to see what's there. Okay, I can do that. So that tells me more about the information about my system. Another common command is called file. File is a way of saying, well, I know I have a file here. What kind is it? So let me go back home. Question?
No, sorry.
No problem. So I want to look at what's there. Here's a list. Well, so what are these? Well, if I want to know, I could say file about, and it would tell me, okay, well, this is what I know as a system about that file. It's a Python script, it's in text, and it's in ASCII. So it gives me information. I could say file movies, and now it says, oh, well, that's a directory. So I can use that to tell what a file is. For directories, it's not so useful, but when you start to have multiple kinds of files from different programs, this can be used to tell you what program created the file. So I could keep going with this for a long time. There are dozens of commands, simple commands like this, but I'm afraid if I keep doing this, I'm going to lose some of y'all. You're going to be fading away. So let's look at some things that you might find are more interesting, especially as you want to be your administrator on your machine. Now, a lot of this you can do with the GUIs available in the utilities. But if you wanted to do something more complicated and tie things together, this is a good way to do it. And I'll touch on that a little later. But now, well, what might be interesting? Well, there's a command called uptime. Only you have to spell it right. Uptime says, well, how long has my computer been running? Well, this tells me that my computer has been running for 7 days and 20 hours. I'm sorry, 7 days and 8.39 hours. And I ran the command at 8:09. That there's two users, me and root. And what's the load averages? Well, that says the load average of the computer is in the last minute 3, in the last 5 minutes 2.78, and in the last 15 minutes 2.52. It's a way of giving you a snapshot of how busy your machine is. There are ways that can be very useful later, but for right now, this just gives you an idea And one of the things that would be most interesting often is how long has my machine been running? Now, many of you have laptops and you'll open them up for the day, run them, turn them off. I have a Mac Mini and it runs 24/7 because I've got various applications on it like Plex that we've talked about before. So it's a server for Plex. So it runs all the time. It rebooted that 7 days ago when the last Mac OS update happened, and it rebooted overnight. So what else might I want to know? Well, what version of software you're running? SWVERS. Now this is a command that is specific to Apple, and it will tell me what version of Mac OS. Well, I'm running Mac OS. It tells me the version 15.4.1, and it gives me the build version as well if you need that information. So that gives you some information. Maybe I want to know what's running on my machine. So PS, process status, pardon me, is the way to do that. So process status, well, I run it and I've only got one process running. And that makes sense sort of because the only thing I'm running right now is this terminal. And it says, yes, you're running the terminal. It's the program that's running in the terminal is the Z shell. So that tells me what I have running. It's the only process that I own. If I want to know more, I can do PS minus capital A, and it tells me all the running processes. And there are a whole bunch of those running processes. Now, obviously, I've got a lot. Well, I can use my mouse and actually scroll backwards through the screen, but still, there are a lot. Reading it this way is not very convenient. So I can use another feature within the shell, and that's called the pipe. The pipe is the vertical bar. That. And what the pipe does is says, take whatever program is on the left, run it, feed the output of that program to whatever the program is take the program on the left and feed its output to the program on the right. So I can use that, and I can use another part of this called the more command. More says, I want to look at a file, but I only want to divide it up into small chunks, small enough to fit on my screen. So where before I ran this PS minus A, and there's lots and lots and lots of processes running, I could now say, well, let me do PS minus capital A, pipe the output to more so I can page through that output. And so now I get the first page. Notice at the top here, PID says the process ID. Every ID process that runs has an ID unique to it. You can use that PID to kill a process, for instance, or do other things to the process. And it tells me various programs and how long they've run. Now, to do this, like before, I could hit enter and go one line at a time, or I could hit space and go through here one screen at a time, looking at all the processes that are running. Not unusual to have hundreds or thousands of concurrent processes running with a modern operating system like Mac OS. Okay, now we get to something that might even be more useful. One thing you often want to do is to search for things. Obviously, we can do that through Finder or do it through Spotlight, look for a file, but you can also do it from the command line. The command line format is, let's see, how do I want to do this? Let's go to downloads. Downloads file, you can see, okay, there's a few things there. don't want to get too many because it makes it easier to deal with my example. So I'm here in downloads. Let me do a ls minus L. ls minus L says do a list, but give me more information. And I may explain this. In the Unix world, every file has file attributes. That's what these things are here. They are the permissions. So this says the first three are for the user, this is for the group, and this is for everyone. So that says this file, don't even know what it is, some audio file I have. I can read it and write it. Everybody else in the world can read it. That's what these R's stand for. Tells me how big it is, when it was created, and so forth. So that's what ls minus L. Remember list we looked at earlier. And it tells me who owns the file. The user, J.R. Purvis, owns it. The group I'm in is staff. For you guys, you probably would never deal with what group. But in a real Unix environment, you could have, okay, this is the build team, this is the programming team, this is another team. That way you could share files amongst yourselves, but no one outside that group would be able to get into the files. So there's a number of files here, and let me do this one more time, ls minus LH, because now instead of showing blocks like it has up here, we have human readable sizes. And that becomes important with what I'm going to do next. Let's say I wanted to search for files. Well, I don't want to search for just a file by name. Maybe I'm trying to cull through my files and figure out where all my space is. So I could say, well, find, looking here, the dot says, here's where I want to look in the downloads directory. Or I could put in the path to a directory if I wanted. But I could say, starting here, I want to look at files by size. Oops. Again, I can't talk and type. File by size, and I want to know how many files are here that are, let's see, greater than 1 megabyte. Now, if I look at these, you see, well, this one's more than 1 megabyte, and well, this one's more than 1 megabyte, and a third one, and a fourth one. So now if I run this command, it just shows me those files. Literally, it just shows me the files that meet the criteria that I've specified. That is, the file size is greater than 1 meg.
It only showed 3 of the 4.
Say again?
That only showed 3 of the 4 that meet the criteria.
Well, you've got 2 JPEG files, which are right there. They're bigger. And then you have 3 XML files from
okay.
And what it's doing, because this is a directory, it dropped down into that directory and found everything within that directory as well. So it's saying, starting here, search everything.
Okay.
So if I wanted to know, well, how could I save space? This is a very easy way to do it. So I can go in, and if I wanted to run it against my massive multi-terabyte external drive, I can say, well, how many files do I have that's bigger than 1 gig? Now, since it's that drive is 8 terabytes, it might take a couple hours or 30 minutes or something, but it could then tell me, well, here's all the files that meet your criteria. Likewise, you could say, well, what's smaller than a certain size? Using a minus instead of the plus. You can also use M time. You could do find minus M time minus M. I can't type. M time. Minus M time. It says it could and say, well, in here, what files have been accessed in the within the last 30 days. So I could say M time minus 30, and that tells it find everything that was modified in the last 30 days. What did I do wrong here? I think I was having trouble with this the other day.
Illegal option.
Yeah, it doesn't like M.
Do you need the
Let's
period?
just look at it, man, M time. See, they don't have anything for, man, fine. So here, if we look at find and we look down here, notice there is a M time. And so it should work. Doesn't like M. Oh, operator error. I forgot to say where to start searching. So they here. So let me go in M time, less than 30 days. And now it says, oh, okay, these files were all touched. They were opened in the last 30 days because that's what I've specified. So I could say, was it modified in the last 30 days? Was it modified more than so many days ago? Was it accessed within a certain period of time? And so forth, kinds of searches. You could also do something says find files that are newer than a given file. So you find a file out there that has a date to it, says, well, find all files that are newer than this file, for instance. So you have a lot of power of creating these different, very complex searches to find things. So let me clear this and if I want to know what disks I have on my system, for instance, how many are mounted, I could do ls, looking at the root directory. And at the root directory, here are all the directories. So notice users is one of the directories. It's one of the lowest level directories that contains all the user accounts. So I could say, well, looking at these, one of them is volumes. Volumes is the directory where all files are mounted, whether it's your hard drive on your system or a removable drive. So I could do an ls minus l volumes. ls slash volumes. And it would say, well, here's what I have. I've got my hard drive. I have an extremely large external drive. I call it Drobo simply because I have scripts and it's just a fixed drive. And I've got a time machine drive and I got a DVD in my DVD player. So that tells me what's there. How big is it? I might say du minus sk and for where I am, and let's wait a minute. Let me do a CD slash volumes and then we go to Drobo. We saw that was a direct file and I want to go to a directory I have there. Okay, that's why. So
Can I recommend a good ebook on this topic while you're working on this?
go ahead.
Allison Sheridan, who has been a frequent guest on with us, has written a book with Bart Busschots called Taming the Terminal, and it goes step by step through all the different uh, commands you might need, and it's perfect for beginners.
Yes, in the slides, I didn't get to the last one, but in the reference section, I listed a couple of sites. Some of them are websites. There is a document that is called something along the lines of beginning Unix command or Unix commands for the beginning mage or something like that. But it's a PDF that goes through and talks about how you do a variety of things at the Unix command line level. And the link is in the slide deck if you were interested in getting that PDF. It's a fairly large document. Okay, I'm going to abandon what I'm doing here because I don't want to put any of you guys to sleep. So let's say I want to find out I'm there. Don't want to run this there. I run. Okay. Let me just jump ahead to something else. I thought I had everything in advanced here, but obviously I didn't. So let's go to CD. Go to there again. And I want to say, well, how big is that? I can do DU minus SK, and it will tell me how big it is. So that's how many blocks it is. So let's say I wanted to know, well, how many files are in there? Well, I can take advantage of something we did earlier. I can say ls minus L. That lists all the files. I can use the pipe to send that output to another command. One of those commands is something called WC or word count. Word count has the option of saying, I don't want to count words in the file, but I want to count lines in the file. And so now, if I look at it, it tells me that in that directory, there's 18 files. So this kind of gives you a feel of how you can combine commands together. Okay, so did that. So that gives me some simple things. Let me jump on to something else that you might want to be interested in. There's a command called ping. Ping is used to send a packet to another site. You can ping any URL. So for my point, I'd say I want to say capmac.org, and I can ping it. And so what it does is it goes through, and once a second, it's sending out a ping. And a ping is just a particular kind of packet. The packet says, send it out to the destination sends it back. And so it times that. And so that's what this is showing, that it says from this IP address, which is my machine, it's going to send a packet out It's a small 64-byte packet. It goes out, comes back to me, and that transition happened in 11.797 milliseconds. Now, why would you want to use that? Well, at the grossest level, you might say, well, I can't get to this website. Is it up? I could ping that website, and then you know, well, does it respond or not? That would tell you whether it was up or not. The ping time might tell you about the quality of the connection. If I go to a site that I go to frequently and I know that the ping time is 11, 12, 15 milliseconds, then you go to it again and I'm having difficulty loading from that site, and I run a ping, and now the times are much greater. That says that there's a whole lot of network traffic, that it is congesting the line, the packet that's being sent from me out, and then the response coming back in. And this will work on any URL. So, okay, I did that. We're going to get through a lot more than I thought. So another useful command, we have system status, I think it is, that tells you your system status, but you can also run the top command. Now, this top command shows you every running process, as well as a lot of data about your machine. So it's telling me load average right up at here, and this is load average at 1, 5, and 15 minutes. It tells me CPU usage, and how much is the user time, how much is the system time, and how much is idle time. So we can tell you a lot about what's going on in your machine. It tells me that I have 23 gig of memory and information about that. Then it talks about packets. When you're transmitting things, you are transmitting packets. A file might be one packet. It more likely will be dozens or hundreds or thousands of packets. So you can see here how you're seeing network traffic coming into your machine and network traffic going out of your machine. Today, we have so many things running that are keeping track, keeping synchronized, that we have lots of processes running. For instance, now a lot of it is Zoom. And if I look here, what is the most active process right now? Zoom is hopped away. Zoom is the most active process. It's using 40% of my CPU. I'm not sure I believe that. It's probably 40% of one CPU. But it tells me a lot of things. It tells me what port it's operating on and so forth. So if you're trying to look at your system and find out what's going on, where there's a program running and it's giving you a trouble, this is the way you can do it. And there are ways then to go, for instance, oh, my machine is running, it's 100%, I can't get in. What PID is the process that's running? And then I could get to the command line and say, kill that process, and it would kill it. And it would free up your machine. That often happened in the Unix world when things would run away. It doesn't happen so much on the Mac, and you have the ability on the Mac to go up and say, what is it, terminate a command?
Force quit.
Yes, force quit. It's the same equivalent. But this is probably the most interesting thing that you might use of all the stuff I have told you yet this evening. And we're just barely touching the surface of all the commands that are available to you. Because for the most Unix people, what they would do is use these and then combine them together in scripts to extract information and alert you to something or to write a report about things. So this is just a high-level look at what's available at the command line on your Mac OS system. Does anybody have any questions? Say again?
Command that people might find useful, that's grep.
Yes.
Can you tell about grep?
So yes, grep, we have a lot of unusual command names in Mac OS. So let's do ls-l. So there's a lot of files here. Think we did it on a big directory where there were hundreds of files. I'm looking for one particular file. Let's say I want to look for any file with DSC in its name. We have 3 of them here, or 2 of them here you can see. So I can do an ls-l, pipe it, that vertical bar, to grep, and then put DSC. DSC then, if I run it, it takes all the output from the first command, pipes it into the second, and now it looks for every line of data. And as Jim suggests, it's looking for a string that's in there. So in this case, I said, look for the string of DSC. If you get into it, there's a lot of ways where you can do a lot of other things. For instance, let's say I do something like that, but let's say, well, I want every file starting with the letter D. So there's all the files that are starting with the letter. That's the only file. That's not right.
John, how did you repeat the last command? Like you didn't have to retype ls space minus L.
Well, there's something called history. History.
Oh, hold on.
Type right. There we go. History says, here's all the commands that I've executed, and it shows me in order here, the last 10 or so commands. Right. If I want to bring back a command, I hit the up arrow, and it brings back the last command, and then I can page back through all the things that I've entered.
Oh.
You're doing the same thing over and over again. It's a quick way to retyping things.
Is that built into the shell, or is that something you had to add?
It's in the shell. Something built into the shell.
Oh, that's pretty cool. Great. So up
just like the auto completion was by hitting tab.
Ah, okay. Wow, that's handy.
Why is it not doing what I want? But this is when you do ad lib demos, things do not always work where you want to try to work them.
Alias is a good way to do that.
Yeah.
Huh. Yeah, some of these things like ls, I imagine you explained this since I got on late, but ls is list, minus L, I think is, I don't know, we'd have to look at it.
Long.
Grep is get regular expression.
There we go.
Yeah.
To put it within within quotes. So, and that really didn't do what I wanted it to do either. Okay, well, I haven't touched Linux in several years, so.
Yeah.
Without the quotes.
But you can do very complex explanations or combinations of letters.
Do it without the quotes.
Say again?
Oh.
Do it without the quotes.
Yeah, I did that before and it didn't like it. It didn't find everything.
Mm.
I don't see it.
Well, this is where the man pages are your friend.
Yeah, but this is not in your man page as much as you're looking at
Oh, you could do man space grep, I suppose.
Well, yeah, but it's not going to tell me how to use a wildcard character, which is what the splat means. The
good
asterisk.
Point. Yeah, exactly. Yeah.
So let's try one other thing before I give up. But that just gives me everything. It's not helping.
Is it what, a minus?
No, it's I'm wanting to give it a string that says include wildcard characters, and I don't remember how to do that off the top of my head.
Do you know which particular shell model you're using? Like
this is Z shell.
I think they keep harassing me to use bash, which
by default Apple uses Z shell.
Oh, okay.
When we were looking at environment earlier, you see the
Z shell right there.
In there somewhere.
Yeah. /bin/Z shell. Yeah.
There's the shell, and you can change it. TSH, you can use bash. You can change it to one, but by default, it's the Z shell for Mac OS.
Mm.
So that went faster than I expected. I thought it would take longer. So I've run out of commands here.
I think there's one thing you might want to bring up that in the command line, you don't, it doesn't, there is never a request, are you sure? So
That's
whatever you tell it
correct.
to do, it does. So you need to be careful.
Very.
You can get yourself in very bad trouble
Yes.
if you're not careful.
Fortunately, most of those dangerous situations are protected from you. Now you can do all sorts of things to your files. So I could go in and accidentally say delete everything, and it would delete everything in my directories.
Yeah.
But it won't let me delete things in the system directories or in other users' directories. You know, no, I guess we went into evening mode to switch the lighting. So any questions? I hope this hasn't been too boring for you guys.
No, it's good.
I used to live this for
Brings
years.
back old times.
John,
Yes, sir.
can you show us one more time how you got to your terminal screen? You did something that I didn't get quick enough.
Okay, let me share my screen. Let me just kill this over here. So let me just share. Oh, shit. You should see my desktop.
Yes.
Mm-hmm.
Okay, so if I go up, you should be seeing my desktop.
Yes.
I go to Go, Utilities, Terminal. And there you go.
Okay. Thank you.
And let me stop sharing again. So back to you, Jim, unless someone has any other questions.
Okay, I think you did a great job. You're kind of bringing back old times because I've, got started, with the, Apple II and DOS and Unix, back in the old days. So it kind of brings back some old times.
What, into the early 90s before Windows became a thing. So most computation before that was all at the command line.
Yep, I say it brings back old times.
Yeah, I remember reading all that stuff to Tommy, all those command lines. Jeez.
Yeah, the Take Control book people have a good one on the terminal.
Oh, for sure.
Let me get. That I just pasted in the chat the book I mentioned before, the PDF that starts at the very simplest level and works up to using most of the commands we talked about tonight and some others, as well as an introduction to shell scripting and some other things.
Okay.
Okay. I guess that about wraps things up. I guess the next thing will be coffee on the, I believe, the 29th, Thursday, 29th. Does that work for you, John?
Let me look. I think I have it in my calendar. Yes, it would be the 29th, and it's already on our calendar on that day.
Okay, well, we'll be seeing y'all then. And thanks for
Hope so.
everybody coming.
Excellent. Great.
Thank you all.